Algebra 2. Funny seeing you guys here. It's crazy that we just keep meeting this way. Okay, I know that was lame. But hey, if you notice, I might be wearing the same outfit because I'm trying to make as many videos in one day as possible. So I promise I don't wear the same outfit 2 days in a row. Not too frequently. All right, I'll try not to. Hey, again, miss you guys. Hope you're doing good. We got section 3 coming at you today. We are talking about independent and dependent for probability. Independent meaning you have two events occurring, and these events can occur without them affecting each other. Okay? So in other words, if I'm flipping a coin and I flip it and I get tails, and then I pick up that coin and I flip it and I get heads, those events did not affect each other at all. Now, a dependent example would be, let's say that I have a bag of marbles and I got red, white, and blue marbles in there. If I pick a blue marble out and I keep it and I don't put it back in the bag, and then I pick another marble out, you see how the probability changed the second time. Because what did I change the second time? I changed the total number of marbles that were in that bag. So that would become a dependent event, okay? So we're looking at those two different styles, independent, dependent. Again, I want you guys to follow along in the book with these videos. If you're not, it's gonna be a little bit of a waste of your time here. Unless you're just copying everything down, you're gonna go back and rewatch it, that's great. Rewatch it as many times as you want. It's gonna be helpful. The more you watch, the better you get. You get questions, ask those questions, and make sure you guys are keeping up, always watching these videos, because that's the best way for me to present the material to you. All right, let's jump into it. You got 3 key terms in this section. You got 2 equations in this section. You're going to need to make sure that you are copying all those down. Follow real close. All right, if you guys haven't figured this out yet, section 1, section 2, those are long. Lots of words are being presented to you. And amazingly enough, we have another section where there's a lot of words here because probability deals with the concept. How do they phrase something? They're telling you something for a reason. And sadly, many times that reason is what could change how you solve it. So you got to pay close attention to the words. All right. So we're going to go through these examples, 1A, 1B, 2, 3A, and 4, all of them, A, B, C. Okay? So let's start here with 1A. We are, let's see, we're talking about a number cube. All right, so again, they use number cubes a lot with probability, and don't forget number cubes have 6 sides for a total of 6, 1 through 6 with our numbers. That's going to come up a lot. So on 1A it says you are rolling a 6 on one number cube and a 6 on another. So this would be an example of, write this up here, 1A. This is going to be independent. All right, because I can roll a dice, get a number, pick up another dice, roll it, get a number. They don't affect each other at all. So they're asking again, I roll a 6. Well, how many 6s are on a number dice? There's only 1 6 on that number. So I have a 1 in 6 chance of getting it multiplied by the exact same thing, because they want to know if I roll it, I get it twice. So we got a 1 over 36 chance, because they asked, I roll a 6, there's only 1 6, there's 6 total numbers, I roll another 6, and again there's 6 total numbers. Let's take a look at 1B. All right, tossing heads, then tails. All right, so again, coin's got 2 sides. That's 2 total possibilities that we're looking at here. And I believe they're giving us 3 different things. We have a head, and a tail. 2 sides on all these coins. There's only 1 head, and 1 tail. So multiply all 3 fractions together for a total of 1/8 being our probability. that you will get a coin to land on head, head, tail. Now, if you remember back in the last section, we talked about theoretical and experimental. So theoretical, this is all theoretical. This is the math behind what these events can produce. The experimental would be you actually do it and see how many chances or how many tries it truly takes to get there. All right, so there's 1A, 1B. I need to turn the page with me to 813 for us to do number 2. All right, let's clear out some space. And let's take a look at number 2. All right, again, you guys are going to need to reference the chart that's near the bottom of page 812. It's another one of those. You have a red cube, a blue cube, or a black cube, whichever color they're giving us here. And you have 2 of them that are being rolled. All right, so number 2 says, the red cube shows a number greater than 4, and the sum is greater than 9. So what you are looking at here is these are dependent events, right? Okay? Dependent events because one thing also plays a part in the other. So the one that they give us is you have a red that is a greater number than 4. Let's take a look at the probability of getting that. If you look at the chart on page 812, count how many in that chart have a red number that's greater than 4. And there's going to be 12 out of the total 36 possible. Go ahead and reduce that fraction. So there's a 1/3 that red's going to be greater than 4. And that's a key word. And I'm going to underline that because that's going to let you know this is dependent. There's 2 things that are playing a part in each probability. And the sum, so addition, is greater than 9. All right. So now what we're looking at is take a look at that chart. And if you look at that chart, one thing that you're going to notice is that at the bottom of that chart, the last 2 rows are the only rows that we're really talking about here, because those are the 2 rows where red is a greater number than 4. How many possible combos are in those last 2 rows? There are 12 possible combos in those last 2 rows. Those are the rows where you have the number 5 and the number 6 for the red dice. And why do we care about that? Because 5 and 6 are greater numbers than 4. All right, now the next part is in those 12 possible combos, how many of those have a sum when you add both dice together that's greater than 9? And there's only 5 possible combos where the numbers, when you add them together, are greater than 9. So now what you have is now you have your 2 dependent events. You have this one right here being greater number than 4, a 1/3 chance, and the sum is greater than 9. So when we multiply these together, we get 5/36. And that is the total. That's our probability of getting a red greater than 4, and when we include the blue, the sum is greater than 9. Okay? So that was for number 2. Now let's take a look at 3, part A. So now I'm down at the bottom of page 813, and you will have to use the chart that is in example 3, and specifically what we have here is you're really going to want example 3, part A, to help us with this 3A. Okay? So let's read the question. What is the probability that a voter from Travis County voted for someone other than George Bush or John Kerry? So what we are looking at here is we need to first figure out what's our total. And our total is going to be determined by the number of voters in Travis. And what do we want? We are looking at basically the other. Because what they are saying is they want other than George Bush or John Kerry. So there's only 3 categories. If you look at that chart, you've got the George Bush, the John Kerry, and the other. So let's first figure out how many total voters were in Travis. And you're going to get 350. Now, how am I getting those numbers? Because if you look at the chart, you're going to see 148 plus 197 plus 5. Those all go with Travis. Now, of those, how many are the other? 5. So this is what we want. We want the other, and we can reduce this down, and let's see, that's going to get us 0.014 chance of picking an other from all of Travis County. All right, so again, how did we get the number of voters in Travis? Just added all 3 together, and the only one we care about is the others. So that's what we want. We put that on top. All right, got a few more to go. Let's clear out some space here. All right, 4A and B and C. Okay. So go ahead and turn the page with me. We are now looking at 814. Okay, we have a bag with a total. Put our info off here. We have 10 total beads in 10 total. And let's see, we have 2 black, 3 white, and 5 red. Okay, stay with me, stay with me. Hopefully you guys are still awake. 12 minutes in, stay with me. All right. Okay, 10 total, 2 black, 3 white, 5 red. Almost done. Here we go. 4A. They're asking us to select a white bead, replace it, and then select a red bead. There's a key word in there. What's the key word? Replace it, meaning you take it out and you put it back in. Did our total change? If I have 10 total, I take out a bead, but then I put it back. What's my total? It's still 10. So that means we have an independent event, because every event after it, as long as we replace it, every event after it has the same probability as the event before it. All right, and the question is asking, select a white, put it back, select a red. All right, so we have select a white is 3 out of 10. We put it back, meaning we still have 10. Select a red, that's a 5. Multiply all this together, 15 over 100. Reduce that down to 3 over 20. All right, let's take a look at 4B. Select a white bead, not replacing it. All right, not replacing it. We take a bead out, we keep it out. Does it change the odds of the next chance? Yes, it does. So this is dependent. All right, now the first one is the one that has the 10 because we haven't taken anything out. So they're saying, all right, you select a white bead, well, there's a 3 out of 10 chance, but we don't put it back. So our total drops to 9. And then the second one is saying, then select a red bead, 5 out of 9. The number of reds didn't change. We didn't pick a red the first time. We picked a white the first time. But the total changed because we kept that white bead out. So multiply these together, 15 over 90, reduce it down, 1 over 6. Okay, last problem here, stay with me, don't fall asleep. 4C says selecting 3 non-red beads without replacing. Don't replace, meaning we take it out, we keep it out. Take another one out, we keep that one out. So this is a dependent. All right, and when it says non-red, that means we're picking out either a black bead or a white bead. So if we add those together, we got a 2 plus a 3. So we have a 5 out of 10 chance on the first one. Again, black or white added together is a 5 total out of 10 total beads. But we keep it out, meaning our total drops, and our total combo of black and white drops from 5 to 4 because we're trying to get another black or white. We do it again. What happens? Our total drops one more time, plus the black or white drops another time. So we're looking at 5, 10, 4, 9, and 3, 8. Multiply all these guys together, reduce it, save you some time. You're going to end up getting 1/12 for that number right there. Whew. Okay. I don't know about you guys, but that's plenty of math for me in one day. Watch it, take notes, rewatch it, do the best you can, keep asking questions, keep reviewing, keep watching, keep watching. That's going to be the best way for you guys to get the material. Go through it, work a problem out, try looking at the video, maybe do a problem before you watch the video, whatever works best for you guys. All right, I'll see you in the next video. Love you guys.